Today we're going to begin with naming compounds. You've already learned how to name covalent compounds, and when we name compounds, that's called nomenclature. You haven't heard that word yet because we threw covalence in our other lesson, but nomenclature is just naming compounds. That's all, super easy. And our covalent is prefix, name, prefix, name. So here our prefixes tell us the number of atoms. So we have 3 sodium. So I start with my prefix, that's tri, and this is sodium. Trisodium. And then we have 2 oxygens, so it's dioxide. So we take our very last atom and we change the ending to IDE. So trisodium dioxide. And if I see this in names, I know I have 3 sodiums. So I write sodium, and this subscript means there's 3 of them. Dioxide, I have 2 oxygens. So oxygen and 2. Okay. Now we're going to learn how to name ionic compounds. And because we know the charges of our ionic compounds, we do not need to use prefixes for the number of atoms. So in covalence, we use prefixes. If you see prefixes, you know it's covalent, 2 nonmetals. And ionics do not use those prefixes. So let's look at an example. Here we have 2 sodiums and 1 oxygen, but we don't need the prefix anymore, so we just write sodium oxide. Why do I know not to use the prefixes? Because I have a metal and a nonmetal, which means it's ionics. So ionics do not use those prefixes. Now you have this worksheet right here, and you are going to be doing this worksheet on a separate sheet of paper. If you want credit for this worksheet, you have to do examples 1, 2, 3, 4 with me on the top of your worksheet. If it's not there, you won't get any credit. So make sure you're doing those examples with me. Our first example has potassium and fluorine atom. So I just named the cation. Cations always come first. So positives first, then negative. And this is potassium fluoride. That's not spelled right. And this should all be on one line, but I ran out of room there. So let's do the next one. I have potassium again. Notice I do have more than 1 potassium. I have 2 of them, but this is an ionic compound, so we are not going to use those prefixes. So I have potassium. And this is oxygen. We change that to oxide. Okay. Second example, we name the first cation, which is calcium. And then our last one, and we ended in "ide", so that's the fluorine atom, and it changes to fluoride. So calcium fluoride. Okay, and here's calcium again. And it's with phosphorus, which changes to phosphide. And that is how we take a formula and write the name. Now we have to learn to take the name and go backwards and write the formula. Let's review how these ionic bonds form. So here's my sodium atom and here's my chlorine atom. As you can see, chlorine's not happy with 7, it likes 8, and sodium comes along and gives it its electron. Actually, chlorine sucks that electron in because it's more electronegative. And then we have this sodium plus, this chlorine minus, and they click together like magnets, and that's how I get sodium chloride. I have 1 sodium and 1 chloride, and they fit together perfectly. So magnesium chloride has a formula with a subscript of 2 by chlorine, and let's see why. So chlorine has 2, 4, 5, 6, 7 valence electrons, so our magnesium can make that happy with 1 more, and I have a full shell on the chlorine, but I still have this guy left, okay? So another chlorine comes along, 1, 2, 3, 4, 5, 6, 7, and now it can give up its other atom. And so now what I have is I have a chlorine with a minus. I have a magnesium with a plus, 2, or 2 plus, either way you write it. And then I have another chlorine with a minus. And these guys all click together like magnets, and that gives me the formula of MgCl2. Okay, why? Because chlorine can only take 1 electron, so magnesium still has 1 to give, and we're in a cup with 1 billion of these atoms, so magnesium gives it to another chlorine, and then these guys all click together, and it ends up being 2 chlorines for every 1 magnesium. Okay, let's look at calcium and sulfur. Sulfur has 2, 4, 5, 6 electrons. It has spots for 2 more. So this calcium goes 1 electron, and then it gives it its other electron. So I have a calcium that turned into a 2 plus cation, and my sulfur, which turned into a 2 minus cation. And we're going to come back to this example. It's going to show you something. But I still have 1 calcium and 1 sulfur, so that is my formula. Now it would take a lot of time to write all these Lewis dot diagrams out, so we are going to go through the shortcut method. It's called crisscross and reduce. And again, these are your 4 examples on your worksheet. You're to do this on a separate sheet of paper. You have to show me your crisscross work, and you have to do these 4 examples if you want credit. So let's start with our example. We have barium and we have fluoride. So I'm going to write barium, and fluoride is, remember we changed that to ide, it's really the fluorine atom, so that's an F there. So the first thing you're going to do is you're going to write them separate like this, and then you need to write the charges above them on top. This is part of the work you have to show me. So barium is down here, okay, and it has a +2 charge. So we've already written these charges on top of our periodic table. If you don't have them, you should write them. Everything in this column is a +2. That's where barium is. And so I'm going to write a +2 above it. And then we have fluorine over here, and fluorine is the fluoride ion, and that's a -1 charge right there. Okay, so if I drew out my Lewis dots, you would see that we would need 2 fluorines for every 1 barium. But instead of writing out the Lewis dots, draw this arrow and move this charge down here to the subscript position and put a 2 there. Okay, and then move this 1 down here. So I have barium 1, fluoride 2, but we never write these ones. So it becomes barium fluoride with a 2 there. Okay, and that is the crisscross method. You need to show me your atoms, you need to show me the crisscross, and then write the correct formula. Okay, so let's go back here and see the shortcut for this. Magnesium forms a +2, chloride forms a -1. If I crisscross it, that 2 goes down there, that 1 goes there, and that's the shortcut to get that magnesium chloride formula. So that's how we do the shortcut for the Lewis dots. Calcium sulfide. This is where the crisscross and reduce comes in play. So calcium is Ca, and sulfide is sulfur. That's an S. My calcium is a +2. My sulfur is a -2. So write that right above them. And then, oops, that's a 2. And then crisscross them. So this 2 goes here, and this 2 goes here. So I have calcium 2, sulfur 2. But we crisscross and reduce. So I can divide both of these by 2, just like you reduce a fraction, and I get calcium sulfide, and that is my formula. And now if we remember back here, my calcium has 2 electrons, and my sulfur has 6, so it can take those 2 electrons. So it really is 1 calcium and 1 sulfur. We do crisscross those charges, and then when we reduce, we get the correct formula. So remember, we are always going to crisscross and then double check to see if we can reduce. Sodium, Na, chlorine, is the chloride ion. Sodium's a +1 because it's in that group. Chlorine's a -1. Okay, just to double check, sodium +1, chlorine -1. Crisscross, that's a 1. Crisscross this down to here, and I put a 1 down there, so our charges just go to the opposite ion, and they become a subscript. Okay, here's my -1, this one. And that's going to give us the formula of sodium chloride. And what we're doing is we're determining these subscripts. Okay, let's check out calcium phosphate. Calcium, and it should be calcium phosphide because that's the formula, but it's the phosphate ion, and calcium's a +2. Phosphate is a -3. I'm going to crisscross and turn them into subscripts. So my 3 goes there and my 2 goes there, and you have to show me this if you want credit. So I have calcium 3, phosphorus 2. So I have calcium phosphide, and these are the correct subscripts. So that is the crisscross and reduce method. And you can finish up the rest of your worksheet, do it on a sheet of paper, show me this work if you want credit.